Hi, today we are going to talk more about one-dimensional motion, but we are going to specifically focus on acceleration and how to determine direction of acceleration and what they mean. So as we have already learned that a direction in one-dimensional motion is specified by positive and negative signs. So in most contexts, the positive and negative signs have very similar meaning. For example, if you're given a displacement of negative 10 meters, that just means the object you're considering has moved a distance of 10 meters in the negative direction of the coordinate axis. And remember, coordinate axis is arbitrarily chosen by you. So you can set your positive direction, and with respect to that positive direction, this negative means the object is moving opposite to the direction you have chosen positive. That's just it. Similarly, if you consider a velocity of negative 10 meters per second, that just means the object is moving at a speed of 10 meters per second, but in the negative direction. So then we consider acceleration. Now acceleration is a bit different, but first let's recall acceleration is equal to delta v over delta t. Now delta v is nothing but the change in velocity, because it is the difference between the final velocity f for final and initial velocity I for initial. So well, as we know, velocity is a vector, so acceleration is also a vector, and delta t is just the change in time. Time cannot be negative, so only thing that can be negative in this equation is delta v, which causes acceleration to be negative. Now a negative acceleration can mean two different things. So in the context of most other vectors like displacement, negative acceleration can mean that the object is moving in the negative coordinate axis direction with increasing speed. So velocity is increasing but in the negative direction, and we say that delta v is negative due to the fact that v is increasingly negative. For example, your initial velocity might have been negative 6 meters per second, but your final velocity is negative 12 meters per second. So we say in this case we have negative acceleration. So you're speeding up but in the negative coordinate axis direction. Another thing about this negative acceleration is delta v is negative, but it is negative due to the fact that vf is smaller than vi. What does that mean? It means that vf is approaching, or velocity is approaching 0. So velocity is getting smaller as you go forward in time. So you're moving in the positive coordinate axis direction, but you're slowing down. That means you have a deceleration. So these are the two meanings that a negative acceleration can have. So we have to be a little bit more careful when dealing with acceleration. Okay, so let's try and look at an example. Okay, so let's see what the problem is first. You're driving at 35 miles an hour when a dog, so let's underline the variables. So we are driving at 35 miles an hour when a dog runs across the road, which you notice, and you then slam on the brakes and slow down to a speed of 10 miles an hour in 2 seconds. What was your average acceleration? Okay, so we are mentioning that you're actually calculating average acceleration, which is defined as this formula right here. And we're given some conversion factors. 1 mile can be either 1610 or 1609 because these two numbers are approximations. And 1 hour is exactly 3600 seconds. And so let's begin. So first of all, in physics, we will often try and draw a figure, right? So the figure may look like this was my initial position, okay? So this was my initial position, and then you see this dog, right? And then when you see this dog, you were moving initially from in here. You see this dog and say this is your final position after you have slowed down. So initially we set our time to be 0 and t final is 2 seconds, okay, because we have slowed down to 10 miles an hour in 2 seconds. Now this is the dog. This is just as you notice the dog, and then this is your position finally, and so you don't hit the dog. Okay, now let's note down everything that we're given to make our lives easier. So we have VI given to us as 35 miles per hour. We have VF given to us as 10 miles per hour. We have delta T given to us to be TF minus TI. Now TI can always be set to 0. Most of the time can be set to 0. So TF is 2 seconds. And what else? And we are looking to find average acceleration. Okay. All right. Now we see that here we have hours, but here the time is given in seconds. So it is better for us to convert from the beginning to SI units. So 35 miles an hour would be 35. You're going from miles to meters. So bigger to smaller. So you multiply by the conversion factor. And per hour, so per means there is a division, and then in the denominator you're going from hour to second, so bigger to smaller. So again you multiply the one you had, the 1 hour, times 3600 seconds. Okay, you do the same here. Okay, so what do we have? Let's see. We end up with 15.6 meters per second and 4.47 meters per second. Okay, now I forgot to do this, but you should do this every time you start a problem, is define your positive direction of motion. So for me, I'm defining rightward to be positive. So initially you were moving right with the initial velocity VI, and finally you slowed down, but you were still moving to the right to in the positive direction with the speed or velocity VF. Okay, so both of these are actually positive. Let us calculate average acceleration. Therefore, average acceleration is equal to VF minus VI over delta T. And what is VF? It is, so again these are both vectors, 15.6, actually sorry, VF is 4.47, VI is 15.6. So 4.47 minus 15.6 over delta T, which is 2. Okay, so if we solve this, we get an answer which is negative 5.57 meters per second squared. This is the unit for acceleration. And what does this negative tell us? Well, this negative satisfies the second condition in that delta V is negative, but because of Vf being smaller than Vi. So Vf is actually decreasing in the positive direction of motion, and hence we have a deceleration. Hopefully that makes sense.